Hello students, next we will try to understand a concept called as modulation. I gave you a brief idea in the previous video of types of communication. So the last type was baseband and modulation communication. So in baseband, original signal is directly transmitted into space, and in modulation the characteristics of the signal is changed and then it is transmitted. That is what is called as modulation. I also gave you an example. We will elaborate that same thing in this topic. Okay, so the topic which we will try to understand is modulation. Okay, first we should understand why modulation is necessary, why you need to change the characteristics of the signal before transmitting it into the space or through wired communication, whatever it is. Okay, so first we have to understand the necessity of modulation. So that is what we will going to understand, necessity of modulation. Okay, so there are three points which we will discuss under the heading necessity of modulation. The first being, as I told you, if you suppose audio signal has to be transmitted. Let us take an example of an audio signal being transmitted. Okay, so if an audio signal has to be transmitted, just for an example, if you are standing on your terrace and if you speak out loudly, how far this signal will be transmitted? The signal will at the most it will reach, say, 100 meters or 200 meters or 300 meters, right? But what happens to the signal strength after 1 kilometer, after traveling a distance of 1 kilometer? Of course, nobody standing at 1 kilometer will hear your voice, right? Because the strength of the signal will keep on decreasing with the distance it travels, because the energy associated with an audio signal is a low frequency signal which is within the range of 20 hertz to 20 kilohertz. Okay, 20 hertz to 20 kilohertz. So these are very low frequency, audio frequency. So this low frequency signal, the energy associated with the signal is very less. And if the energy associated with the signal is very less will be the distance traveled by the signal. Therefore, you cannot transfer original signal directly into the medium, that is space. Of course, if you are talking about space, you cannot directly transmit the signal into the space. That means there you need modulation. So the first point under the heading of necessity modulation is poor transmission. Okay, so what we said is energy associated with the signal is directly proportional to the frequency. Okay, so if frequency is less, energy is less, distance traveled will be less. So of course, if you have to transmit your audio frequency at a long distance, you need to change the characteristics, you need to modulate, and that is why modulation is necessary. So that was the first point. Okay, poor transmission. Second is interference. Just imagine that all radio channels are transmitting audio frequency, original audio frequency, directly into the medium. You just imagine the scenario. There are so many radio channels, है ना, 93.5 है, 91.1 है, 92.94 पॉइंट समथिंग, देयर बहुत सारे रेडियो चैनल्स है. और इमेजिन करो कि वो सभी चैनल एक ही फ्रीक्वेंसी ट्रांसमिट कर रहे हैं. which is within the range of, or suppose audio frequency original signal directly transmit कर रहा है within the range of 20 hertz to 20 kilohertz, and almost all the frequency will belong to a same band, same frequency band. So what will happen is they won't travel individually, instead they will mix with each other. That is what is called as interference. That means when we say interference, same frequency signal cannot be directly transmitted into space. Same frequency signal cannot be directly transmitted into the medium. Of course, we are talking about space, so it cannot be transmitted. So radio frequency cannot be transmitted directly. Okay, which has a frequency range of 20 hertz to 20 kilohertz, because they will interfere with each other, and what we will get is nothing but noise or disturbance if you relate it to the electronics. Okay. And the third is the most important, is height of antenna. Of course, any electromagnetic signal which you transmit, to receive that electromagnetic signal you need an antenna. So we are talking about height of antenna. So height of antenna is lambda by 2. Lambda means wavelength. Okay. So what is wavelength? Wavelength is your speed of your signal transmitted, that is 3 into 10 to the power 8 meter per second, speed upon frequency, right? So 3 into 10 to the power 8, and frequency, of course, if you are talking about original audio frequency, let us take it the maximum value, that is 20 kilohertz. So 20 into 10 to the power 3, this can be written as 3 into 10 to the power 8 upon 2 into 10 to the power 4. This is 1.5 into 10 to the power 4, or I can say it is 15 into 10 to the power 3. So 15 kilometer. Okay, so that is the length, wavelength, lambda. And what we said, what should be the height of the antenna if you are transmitting original signal directly into the space? To receive that, the height of the antenna should be lambda by 2. And what is lambda? Lambda is 15 kilometers. So what is lambda by 2? It will be 7.5 kilometer. Is it feasible to have an antenna whose height is 7.5 kilometer? Just imagine that all the radio channels are transmitting original signal, and say without interference it has reached to your mobile phone. Now the mobile phone, to catch that particular frequency, should have an height of 7.5 kilometer. Is it feasible? Of course not. So for all these three reasons, it is very important that modulation should be done. Okay, so modulation, if somebody asks you to define modulation, it is a process in which characteristic of high frequency signal is changed in accordance with the original signal. It is a process. Of course, in generalized term we say it is a process of mixing two signals, but what we are doing is, as I told you in that example, that if you want to transmit audio signal, you have to mix that audio signal with a high frequency signal. So 93.5 megahertz is the carrier frequency, and you have to mix the original frequency with the carrier frequency. The process will be called as modulation, right? if you remember, it is called as 93.5 megahertz FM. FM stands for frequency modulation. We will try to understand what exactly we mean by frequency modulation in types of modulation. Now you have to understand that before transmitting, the original signal and the high frequency carrier wave is mixed. The way in which they are mixed and the characteristics is changed. On the basis of that, we will classify modulation in different types. Okay, so that is what we have been. It is a process in which characteristics of a high frequency wave is changed in accordance with the original signal. That is called as modulation. The three types of modulation which we will try to understand is amplitude modulation, second frequency modulation, and third phase modulation. Okay, there are a lot of mathematics which has been specified, the number of derivations which has been specified in the book. It is given in the book for these topics: amplitude modulation, frequency modulation, and phase modulation. It is not at all necessary, never been asked in the exam, and this year it has been omitted, that the mathematical part. You just have to understand the basics of what exactly we mean by amplitude modulation, frequency modulation, and phase modulation. Of course, we need to understand the diagram. Okay, we have to understand, we have to represent it diagrammatically. We have to understand it in the form of definition. So these two things are very important for these three topics. Okay, so I hope you have understood the basics of modulation. In the next part, we will try to understand the different types of modulation with its definition and diagrammatical read.